Happy New Year! In this video, I'm going to calculate all 10 of these as a New Year celebration for the 2026 because I love math. So yeah, I'll celebrate it with what I love. So of course. So number one, it says the square root of 2026. So what could that be? So obviously 40. So I'm gonna calculate this all by myself. Okay, I might not explain everything in detail. I'm just calculating all by myself. Okay, and and at the end of this video, I'm going to give you a challenge. Calculate this by hand. Okay, I'm going to calculate all of that by hand, so you should calculate this by hand. No calculators allowed, okay? That's cheating. So I'm gonna calculate all these by hand. No calculators, okay? So calculators can be only used for checking, okay? Checking your answers. Okay. So 2026. That's gonna be x. So we have how. So we're not going to use Newton's method. We're gonna use Halley's method, which says that x of n plus 1 equals x of n minus a big fraction right here, 2 times the derivative of xn squared minus f of x and times the second derivative of f of x, and the numerator is going to be 2 times f of x and times the derivative of f of x. And let me check it. Let me check it in my notebook real quick. So yeah, it's correct. So because we're trying to take the square root of 2026, if we call it x, then it should be true that x squared minus 2026 must be equal to, I should say, 0. Okay, that will be our function. The derivative of the function would be 2x, and the second derivative, wait a minute, the second derivative of the function will be 2. So let's just plug all of these into the function right here. So x n plus 1 is going to be equal to x of n minus a really big fraction. Let's focus on the denominator first. So 2 times this square. So that's going to be 2 times 2x whole squared. I mean x of n. Okay, x of n. 2 times x of n whole square minus the function times the second derivative of itself. So that's gonna be 2x squared. We're gonna put parentheses right like this. 2x squared minus 4052. So we're gonna put. I'll simplify this later. 2 times f of x times its derivative. 2 times f of x. So that's gonna be 2 times f of x times the second derivative, which is 2x. So we're gonna simplify this. Let's focus. I'm focusing on the denominator first because it's much longer. Okay, so 2 times 4x n squared minus 2. I should have put an n there, and there. Okay. Oh, that's gonna be 2x of n squared plus a minus times a minus is plus, so that's gonna be a plus. So 4052 If that method doesn't work, then I'm gonna use Newton's method, okay? So, wait a minute. I'm using Halley's method because it's much faster than Newton's method, okay? So 2 times, and that's gonna be 4 times x of n times x of n squared minus 2026. And then that's gonna be equal to x of n minus a large fraction, a really giant fraction. So 4 times x of n whole cubed minus 4 times that, and that's gonna be 8. 126 times 4. 25 times 4 is 10, so it's gonna be 8104. That's gonna be, and then 8 times x. 2 times 4 is 8. 8 minus 2 is 6. It's gonna be 6x of n squared plus 4052. So we can simplify this a bit further because we can divide both the numerator and denominator by 2. So that's gonna be 2 times x of n cubed minus 4052 over 3x of n squared plus 2026. So that's gonna be our iteration right there. So that's gonna be 45 minus this large fraction. Let me erase something. So let me erase this. So that's gonna be 2x of n cubed minus 4052. Wait a minute. That's gonna be times 45 whole cubed minus 4052. I don't know if that will work, okay? I don't know if that will work. 3 times, I'm worried, of course. Mine plus 2026. So we're gonna erase all of that. 45 squared, that's just 2025. But 2025, let me, wait a minute. So 2 times what? 2025 times 45, that's gonna be 12510. 100, 8,000, that's gonna be 125. 91125. So that's gonna be 91125 minus 4052. And then this is gonna be 3 times 2025 plus 2026. That's a bit large. Hmm. 45 minus 182250 minus 4052. That's gonna be 198. 178198. That's such a large number. 178198. 60, 75 minus 2026. 60, 75 minus 20 plus 2026. That's gonna be 101 right there. That's gonna be a 101. Oh, that's a large number. That's a really large number. So I don't think this will work. Let me check. This is for checking, okay? So 45 minus so it seems that it will work though. It will not. I don't think it will work. So when I tried it on my calculator, it changed to a completely wrong answer. The answer should be obviously that's gonna be between 45 or 46, but this calculator it just showed me around 12.6 something like that. So I'm not gonna use Halley's method. Sorry about that. So we're gonna use Newton's method instead. So 45 minus 45 square minus 2026. That's our function, okay? The derivative, that's gonna be 2 times 45. That's gonna be 45 minus 2025 minus 2026. That's just negative 1. 2 times 45, that's just 90. And then for plus 45 plus 1 over 90, what could that be? Well, this is approximately 45 point something. But what's that? Let's check. So 1 divided by 90 is gonna be 0.01. That's gonna be 90 right there. 0.01, 90 right there. 1, so that's gonna be 0.0111, repeating, so that's gonna be 45.0111. Okay, then we're gonna repeat that, but let's just never mind. So x2 is approximately 45.0111 minus 45.0111 whole square minus 2026 and 2 times 45.0111. Okay, 45.01 square. I think we can use a little bit of trickery. That square, that's gonna be 45 plus 0.0111 whole square. That's gonna be 45 squared. That's just 2025 plus if I made a mistake when I trying to use Halley's method earlier, I don't wanna know it, because you know it, right? If I haven't made a mistake while using Halley's method and still diverges, well, I don't even know what to say. Come on, let's just get back to it. So 2 times 45, that's just 90. 90 times this, that's just 1, right? So if we take 45 and 1 over 90 and then 2, that's times that's going to be 90. 90, that's 90's cancel, that's going to be 1. But 1 over 90 square, that's going to be 1 over 8,100. We're going to divide 8,100 over 1. So that's gonna be approximately 0.001. Yeah, it's gonna be 0.001. So that's gonna be 2026.0001. So that's gonna be our answer. And if we subtract 2026, we get 0.0001. And then if we divide by this large number right there, it's going to be practically 0, right? It's approximately 0. I don't think so. So that's going to be 9. So 45 plus 1 over 90. We're going to multiply that by 2. That's going to be 90 plus 1 over 45. And that's gonna be 45, 0.02 here. That's gonna be 90. 2 here, 90. So 0.90.0222 like that. So that's gonna be 90.02 repeating. If we divide by that, of course that's gonna be less than 0.0001 anyway. But let's just round to 5 decimal places. Just for that. If we 90.222. Wait a minute. Please, what is that? What's that, bro? So what we're trying to divide 0.001 over 90.0222. That's gonna be 0.00000. 1? No. It's gonna be more than 5? No. So it's practically going to be 0. So I think this is going to be our answer. 45.0111. So that is going to be equal to 45.0111. Let's check. Square root of 2026. Oh, so yeah, it's really correct. To 4 decimal places of accuracy. So I'm gonna write that down right there. So it's gonna be 45.0111. Now let's go to number 2. What will be the cube root of 2026? Let's see. Near. So let's say that 2026, the cube root, I forgot that, it's gonna be 10 plus some integer number. No, that's approximately, okay? And let's assume that this is the cube root of 2026 when we round it to the nearest integer. Let's assume just like that. So that's gonna be 2026 is approximately 10 plus x cubed. If we use the binomial expansion for that, if we expand this, we get 1000 times 3 times that square times that. That's gonna be 300x plus 3 times 10 times that square. That's gonna be 30x square, and that's this square, and that's gonna be 1026. If we subtract 1000, then we get 300x plus 30x square plus x cubed. Sorry, that's not. So we're gonna find the nearest integer value, which is still less than this. So I'm gonna find the nearest integer value. So what's that gonna be? Is it 3? Let's check. If x equals 3, then this will be I'm gonna underline that. This will be 900 plus 3 squared times 30. That's just 9 times 30, so 270. And then 3 cubed is 27. That's gonna be 97. So that's gonna be 1197. But if x is equal to 2, this is gonna be then this will be, I already underlined this expression right here, okay? So it's gonna be 600 plus 3 times 4, 2 squared is 4, so it's gonna be 120, and then 2 cubed is 8, so it's gonna be 728. So that's gonna be 728. And if we add 1000 to that, then we will know that if 13 cubed is 2197 and 12 cubed is 1728. So what's the closest? If you like, then pause and think about it. Okay, so I think this will be the closest one. So x is approximately 3, but we're not done yet, because if we stop here, that will not be an accurate approximation for the the cube root of 2026. So so x0, where is x0? x0 is 13. X first is going to be 13 minus 13 cubed minus 2026, which we all know that's going to be 2197 anyway. And then 3 times 13 squared. So let's try to calculate this. 13 squared, that's just 169. So 169 times 3, that's going to be 27. And 6 times 3 is 18, so that's going to be 20. So that's going to be 507. That will be the numerator. And the denominator, that's going to be 2197 over, let me write the long division symbol right there, over 2026. So that's gonna be, no, I mean not the division, I mean the subtraction. Okay, we're subtracting, not dividing. Okay, I almost making a mistake. So that's gonna be 171. So that's gonna be 171 right there. So we're gonna divide two 3-digit numbers. So that's gonna be 171 over 507. So that's gonna be 5 times 3, that's gonna be 15, that's gonna be 21. If we subtract, we get 18. 0.3, again, that's gonna be 1521, that's gonna be 969, 90. 5 times, and that's gonna be 35, and that's gonna be 49. So that's gonna be 41. If we continue, we get 1014. If we subtract, we get 39. And then that's gonna be 7 right there. That's gonna be 49. And then that's gonna be 35. If we subtract, we get 114. Obviously, this code is to do that more than 5 times. This is going to be our approximation. And if we subtract from 13, let me write that over there. And then I'm gonna erase anything unnecessary. Take it my way. So that's gonna be 2, 10, no, 9, I mean 9, 9, 9, 9, 9, 10. So that's gonna be 2, that's gonna be 7, that's gonna be 2, that's gonna be 6, that's gonna be 6, and that's gonna be 2. So it turns out that this is, let me erase them. So this is gonna be approximately 12.6627. We're gonna go for x2. That is approximately, this is gonna be much more than 19. That's gonna be much more difficult. So 12.66272 minus 12.66272 cubed minus 2026 all over 3 times 12.66272 square. That's gonna be a big problem because we're gonna have to work with a lot of digits. Anyway, let's just get into it. So that's gonna be 12.66272 square. That is going to be 12 square, which is 144, plus 12 times 0.6. I don't think we can use this trick. Let's just multiply it immediately. So 12.66272 times 12.66272. That's gonna be a lot of mess right there. I'm gonna multiply, that's gonna be 454, 12, 13, 5, 2. And then that's gonna be 7 times 2 is 14, 7 times 7 is 49, so that's gonna be 50, so 2 times 7 is 14, that's gonna be 19, and then 6 times 7 is 42, that's gonna be 43, and then 6 times 7 is 42, so that's gonna be 46, and then 2 times 7 is 14, so it's gonna be 18, that's gonna be 8 right there, 2, that's gonna be 2, 5, 3, 2, 5, 4, 4. 6 times 2 is 12. 6 times 7 is 42. That's going to be 43. 6 times 2 is 12. So it's going to be 16. And then 6 times 6 is 36. It's going to be 30. So 6 times 6 is 36. So that's gonna be 39. Now 2 times 6 is 12. That's gonna be 50. That's gonna be 7 right there. 12 times 6 is 72. Okay, so 7, 5, 9, 7, 6, 3, 2. And then there's 2 right there, so that's gonna be 2, 5, 3, 2, 5, 4, 4. And then lastly, that's going to be 12.66272. Even though, you know it. So if we draw a line right here, and then we're going to add 8, 4, 9, 6 plus 11. That's going to be 17. And then 3 times 3 is 9, that's 10, so it's going to be 17. And then 5 times 6 is 11, 12, 14, 20, that's going to be 27. 2 times 2 plus 8 is 10, 12, 15. So that's going to be 12, that's going to be 22, 22, and that's going to be 10, that's going to be 32. 32 plus 2, that's going to be 34. And then we have, that's going to be 11, that's going to be 11, that's going to be 16. And then that's going to be 25, 25, 30, 32. 32 plus 12, that's going to be 44. That's gonna be 4 plus 5 is 9. That's gonna be 11. 11, and that's gonna be 20. So it's gonna be 24. Almost done. And then 12 plus 9. That's gonna be 21. So that's gonna be 23. And then 9 plus 11, that's going to be 20. It's going to be 160. That was a lot of mess though. And that is for this squared should be 160.34448. So if we multiply by 12.6272 again, oh nah. No. Let's just do it again, okay? So, what's wrong with this thing? So that's gonna be 160.34448. 34448. And then we're gonna multiply it by 12.66272. Okay. 8 times 2 is 16. That's gonna be 96. 886.320. Oh, that was easy. 7 times 8 is 56. 4 times 2 is 28. It's gonna be 33. 4 times 2 is 28. So it's gonna be 31. 28, 31. And then 3 times 7, that's gonna be 21. That's gonna be 24. 6 times 7 is 42. And then that's gonna be 11. Multiplying by 2 again, we get 320.68896. And then 6 plus 8, that's gonna be 48. 6 times 4 is 24, so it's gonna be 28. 6 times 4 is 24, that's gonna be 26. 6 times 4 is 24, it's gonna be 26. 3 times 6 is 18, that's gonna be 20. 6 times 7 is 36, that's gonna be 96. So that's gonna be 962066688. And then we're gonna multiply by 2 again, which is 320.68896. Then it's gonna be 160.34448. That's fairly nice. That's fairly difficult. So that's gonna be 15, 9, 10, 18. And then 10 plus 17 is just 27. 8 times 3 is 24. 24, 25, 25, 27, 27, 30, 33. And then this is gonna be 2 plus 3 is 5, 7. That's gonna be 10. 6 times 3 is 18 plus 17. 18 plus 17. That's gonna be 35. 35 plus 7, that's gonna be 42. 42 right there. And then 4 plus 3 is 7. 7, 9. 9. 9 plus 6 is 15. 15 plus 12, that's gonna be 27. 2 right there. And then 8 plus 4 is 12, 14, 16, 18, 19. That's gonna be 1 plus 1 is 3, 5, 9, 10. And that's gonna be 10. So we're gonna circle this. 10, 20, That's gonna be 23. And then 6 plus 3 is 9, 18, 20. 9 plus 1 is 11, so it's gonna be 13, 16, 10. And that's gonna be 20. That's going to be... Wait a minute. What's up, little one? That's gonna be 10. I think I made a mistake because... I shouldn't have. There must be a mistake somewhere. When things are this messy, I almost always make a mistake. So there's gonna be 7, 8, 9, 10, 11, 12, 13, 14, 10. I'm confused. How is that even possible? Let me add again. 6, 15, and then see this is now that's gonna be 18. 8 plus 10. 10 plus 17 is 27. Put a line right there. 2. And then that's gonna be 6. 8 times is 24, 25, 25, 27, 30, 33, 33, 33, 33 right there. Okay. And then 4 plus 7, 8 plus is 14, 14, 28, 32, 35, 35. What a problem. 35, and then 2 plus 3 is 5. 7. 7 plus 18, that's going to be 25. 25 plus 17, that's going to be 12, that's going to be 42. 42, right there. And then 3 plus 4 is 7. 7, 9, 9, okay. 9 plus 14, no, I mean 18, that's gonna be 27, and then 8 plus 4 is 12, 14, 16, 18, 19, and then I really can't see it. 6 plus 4 is 10, 10, 18, 19, 20, 21, 23, okay, 9 plus 7, that's going to be 20, and then 9 plus 11, 13, so that's going to be 2030 point. So I fixed the mistake. So the cube one, that's going to be 2030.39725, blah blah blah. So if we subtract it, we get like 4.39725. We're gonna already square. If we multiply it by 3, we get. Can you see it? I think you can. So that's gonna be 8 times 3 is 24. 4 times 3 is 12, that's gonna be 14. 4 times 3 is 12, that's gonna be 13. 4 times 3 is 12, that's gonna be 13. That's gonna be 1 0 right there. It's gonna be 4, 8. That's gonna be 481.0. So we're gonna divide 481 03344 over. No. Divide this thing. 4.43975 right there. That's 8 digits, so that's gonna be 8 digits right there. So that's gonna be 0.009. 4 times 9 is 36. 4 times 9 is 36, it's gonna be 39. 3 times 9 is 27, that's gonna be 30. 3 times 9 is 27, that's gonna be 30. That's gonna be 9. 8 times 9 is 72. And then 4 times 9 is 36, so that's gonna be 43. Okay. I'm gonna subtract. So we'll get 4, 9, 0, 4, 6, 12. That's gonna be 9 right there. That's gonna be 8. That's gonna be 16. That's gonna be 7. That's gonna be 6. And then if we add another digit, that's gonna be 0.091. I'm gonna put this right there. So that's 9, 1, 4, 8, 1, 0, 3, 3, 4, 4. If we subtract, that's gonna be 6. And then this 8 right there, and that's gonna be 10 right there, that's gonna be 9, that's gonna be 13, that's gonna be, of course, that's gonna be 9. And that's gonna be 6 right there, that's gonna be 5 right there, 4, 8. 67 minus 48. That's gonna be 9. This goes into that 5 times. Yeah, I think so. No, it doesn't go into that 5 times. So it's gonna be, I think, 4 times. So 4 times might be the answer. 4 times 4 is 16. 4 times 4 is 16, so it's gonna be 17. 3 times 4 is 12, it's gonna be 13. 3 times 4 is 12, it's gonna be 13. 1, 3, 3. That's gonna be 4 right there. That's gonna be 32 right there. 4 times 4 is 16. So it's gonna be 19. So that's gonna be 5. That's gonna be 10. That's gonna be 4. That's gonna be 8. That's gonna be 5. That's gonna be 3. That's gonna be 4. 0, 6. Maybe another 0 there. So this will be our approximation. And if we subtract 0.00914, then we'll get 8, 5, 5, 3, 12.6. So this is gonna be approximately 12.65358. That's gonna be 6 right there. So our approximation is 12.6536. I think so. Let's check. After we check it, we won't have the end of the bill. We don't have to calculate it anymore because that will be also cheating too. So 2026. 6536. Oh yeah, it's quite a 4 decimal places. 8. So yeah, so let's go to number 3, and it says the natural log of 2026. Right there. Wait a minute. Right there. Okay. So the natural log of 2026, that's gonna be natural log of 2026. So that's gonna be 2 times and then 2 times 1013, and then we can break it. Oh, wait a minute. We're gonna convert this into standard form of base 2. And what I mean that we're gonna convert 2026 into standard form, but we're not using base 10, we're using base 2. Okay? Base 2. Base 2, okay? Base 2. So that's gonna be 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. Really close. So that's gonna be that's gonna be 1024 divided by 2026. So that's gonna be 1024. 2, 1002. Okay, and that's gonna be 1.9. 4 times 9 is 36. And then 2 times 9 is 18. So it's gonna be 21. It's gonna be. Wait, what? No, I don't think so. Let me check for a bit. So 1024. If we divide by 1002 for 2048, that's gonna be 2048. But what about 2026? It should be just less than or equal to 9, right? 1024 10. Oh yeah, I was confused. So that's gonna be 1.9. 4 times 9 is 36. And then 2 times 9 is 18. That's gonna be 21. That's gonna be 9 right there. 0, 4. And then 1.98. No, that's gonna be 97. 1.97. That's gonna be that's a bit hard. 4 times 7 is 28. And then 2 times 7 is 14. That's gonna be 16. It's gonna be 17. It's gonna be 3. That's gonna be 10. So this is gonna be equal to 2. And then 7, 9, 13. So that's gonna be 7. That's gonna be 8. 1.79. 1.978. It's gonna be 32. 2 to the 8 is 16. That's gonna be 18. Wait a minute. 2 times 4 times 32. 2 times 8 is 16. So that's gonna be 19. 8, 192. 1, 10, 8, 6, 1, 1, 2, 5, 0. If we multiply by 5, we get 20. And then 2 times 5 is 10. That's going to be 12, 5, 1, 2, 0, 6, 1, 6, 0. And let's just take 4 decimal places as precision, okay? Because we only approximate the 4 decimal places. So that's going to be 1.9785 times 2 to the power of 10 right there. So we're gonna use something called And then we're gonna, so that's gonna be the natural log of 1.9785 plus 10 times the natural log of 2. Can you excuse me? I need to grab something from above. I'll be back, okay? Okay, so let's continue. So the natural log of 1.9785. Let's just divide by 1 again. So that's gonna be 1.9785 over 2. That's gonna be 0.918. So that's gonna be 9816. 2 times 9. That's gonna be 80. 2 5. That's gonna be 30. So this will be our approximation. So this is going to be the natural log of 0.9893 plus, not 10 anymore, that's going to be 11. So we can rewrite this as wait a minute. The natural log of 0.9893 can be written as the natural log of 1 minus, let me subtract 1. Let me subtract this number from 1. That's going to be 7, 1. That's going to be 0.0107. And then this is something called the Taylor series, which says that, for natural log of 1 plus I, that's going to be x minus x squared over 2, x cubed over 3 minus x to the 4 over 4. Let me check that with my calculator. Wait, where's my calculator? For natural log of 1.1. Let me check for a bit. 0.1. 0.1 squared. So it's right. So I'm gonna do that. So that's gonna be 0.0107 minus, I'm gonna put a negative sign right there. 0.107 0.0107 whole square over 2 minus 0.0 and so on. Wait a minute. I think this pen has run out of ink. But luckily, we have another pen. In fact, we have another 2 pens. So let's just see what's the one. So that's gonna be negative 0.0107. Oh, that's a little bit different. Negative 0.01007. That's just the same as 0.0107 because a negative times a negative is positive. The positive times a positive is just still also a positive. What I'm trying to say is a positive times a positive is a positive. But a negative times a negative is also a positive too. So there's no difference. So it's going to be 0.0107, 0.0107, 49. And this is going to be 7, 107, 11449. We should have 5. That's gonna be 0.0001, but we haven't divided by 2 yet. But if we divide it by 2, it'll be more than 5, right? So that's gonna be 14, 0.00057. And if we subtract a positive from a negative, we just add the positive arguments. Negative 0.010757. And then we add 11 times the natural log of 2. The natural log of 2 is approximately 0.6931, and then we multiply by 11, 6931, that's gonna be 4, 1, 12, and 15, 16, 7.6921, and then we subtract 0.01057, and then we get 0, 9, and that's gonna be 3 right there, 4 right there, that's gonna be 10 right there, 3 right there, 5, 9, that's gonna be so the natural log of 2026 is approximately 7.593343. Let me check. So natural log of 2026. It says so we only actually do 1 decimal place. No way. Wait a minute, let me check. And then we made a mistake. That should be 7.61, not 7.59. I would have made a mistake, so that's gonna be 6.1 right there, sorry. So that's gonna be, let's check again, 2026, so that's gonna be 7.6138. Oh. Anyway. So that's gonna, we're only taking 4 decimal places as an approximation, so 7.6133, but it's, in the calculator it says 7.6138. Oh, so I'm just off by 0.0005. So let me put error. I don't think so. I don't think I want to do that. Okay, what about the logarithm? I mean the common logarithm of 2026. What about the logarithm? I mean the common logarithm of base 10 of 2026. That's just the natural log of 2026. I'm just using the change of base rule, and that's going to be the natural log of 10. The natural log of 10 is approximately, natural log of 10 is approximately 2.3026. So let's divide. I'm trying to divide two 5-digit numbers. That's gonna be a lot of work to do. 2 times 3, 618. That's gonna be 769. And then that's gonna be 2. That's gonna be 13. Look, my guy. So let him sit on my leg. So that's gonna be 12. That's gonna be 5, 7, 3.3. It's gonna be 69078, 4, 10, 2, 14. That's gonna be 7, 1, 0. No. What about this? It's about 7, I think, but let's just go with 6. 6 times 6 is 36. And then 2 times 6 is 12. That's gonna be 15. 3 times 6 is 12. 3 times 6 is 18, I mean. 2 times 6 is 12. That's gonna be 13. That's gonna be 440. 90. And then there's gonna be 4 right there, I think. 4 times 4 is 9, 2. I think that will be our approximation. This will be our approximation. So that's gonna be 3.3064. So that's gonna be approximately 3.3064. Let's check with my calculator. Logarithm of 2026. So it says 3.3066. But it says 3.3061. Not bad. Oh, here comes the beastly one. So it says 2026 to the 2026. So it says 2026 to the power of 2026. That's a really large number to calculate, right? 2026 multiplied by itself 2026 times. Do you know how large would that be? If I try to do that using a calculator, can you see it? And then we're gonna press. I'm gonna let baby press this button right here. So press it. Okay. So that's gonna be. Oh, it shows you an error. My calculator can't handle this. So how am I supposed to calculate that by hand? Okay. That's what I'm gonna do. Don't worry. I can still do it. So that's gonna be 10 to the power of log. I'm using the change of this. I'm changing the base from 2026 into 10, so it's easier to calculate. And although the height will be a decimal, so that's gonna be log 2026 to the 2026. So we will get 10 to the 2026 times the log of 2026. But since we already have this, we can calculate that 2026 times 3.3024. Let's calculate 3.3024. We're going to multiply by 2026. So that's going to be 24. This is going to be 12. That's going to be 14, 18, 19, 48 0 6 6 6 6 0 4 8. If we do the addition, we get 16 right there. 10 plus 9 is 20. 8 9, so it's gonna be 669. So it's gonna be approximately, should I write that? That's gonna be approximately 10 to the 669 0.6624. I should put a decimal place right there. Can you see it? So I'm gonna erase this, and then we're gonna split it into a product of powers of 10. So that's gonna be 10 to the 0.662. I should say that's gonna be 0.6624 plus 6690, and then it's gonna be 10 to the 0.6624 plus 6690. 10 is actually e to the power of the natural log of 10. Okay, that's gonna be 0.6624. I should have written that. 10 times to the 669d, and then it's gonna be, what is biting right now? So if I check 2026 times the log of 2026, 6699. But it just says 669d. Wait a minute. It's practically correct, but 3.3066. Oh, I see. I wrote it wrongly, so I made a wrong calculation. I already made a mistake. That's not 3.002, that's gonna be 3.3064. I made a mistake, sorry, okay? Hey, I made a mistake, but anyway, let's continue calculating. So this is gonna be 3.3064 2026. 6 times 4 is 24. 638. 3 times 6 is 24, and then 3 times 18. That's gonna be 20. 8, 12, 6, 6, and that's gonna be 6, 6, 1, 2, 8. I'm gonna add all them up. That's gonna be 16, 6, and then 12, 13, 8, 9, and then 2 times 6, 9, so it's gonna be 6, 6, 9, 9. Oh, okay. So that's approximately 10.6699.3664. So I'm gonna separate it into a sum. So it's gonna be 0.3664 plus 6699. Now, and by the way, let's check it again. So it's gonna be 66992515. Oh, that's fine. Alright. So that's gonna be 0.03664 times 10 to the 6699. So that's gonna be. I'm not trying to calculate this, okay? Because that will be cheating. So that's gonna be e to the natural log of 10 of 0.3664 times 10 to the 6699. I'm not trying to calculate this by using a calculator. Okay, that will be cheating, and this challenge will be ruined. I don't want to ruin the challenge, so I only trying to calculate this by hand, as I promised before in the beginning of this video. So let's continue anyway. So that's gonna be u times the natural log 2. That's gonna be 2.3026, 0.3664. 6 times 4 is 24. That's gonna be 10. And then 3 times 4 is 12. It's gonna be 92. 6 times 6 is 36. 2 times 6 is 12. That's gonna be 15. This is 18. 2 times 6 is 12. That's gonna be 13. 1, 3, 8, 5, 1, 5, 6. And then multiply by 3, we get 18. 56, 0 right there. And that's gonna be 69. And then it's gonna be 64. 12. And then 8, that's gonna be 13. 15, 17, and then 10, 19. 19 plus 24, 10, 13, 14, 8.4. Wait, what? That's gonna be 0 point. Of course. That's gonna be e to the 0.8435 times 10 to the 6699. So that's gonna be e to the, we're gonna factor sum of factors. 2 times 0. We're gonna divide it by 2, 0.8435 over 2, 0.04242 right there. 3, 1, 1 right there. 15, 7, 14, 5. That's good. 42175 right there. We're gonna divide it by 2 again. 2 times, let me divide that right out there. 42175 multiply by 2. 0. Oh! I forgot something. We can use the Taylor series. We could have just used the Taylor series for e to the x. So e to the x, the Taylor series is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, x to the 4 over 4 factorial, plus and so on. So let's just calculate it anyway. So 10 to the, wait a minute. So we're gonna use brackets. 1 plus 0.8435 plus 0.8435 squared over 2 factorial, 0.8435 cubed over 3 factorial, plus so on, times 10 to the power of 6699. Like this. So that's gonna be approximately, we're gonna add 1.8435, but that's not it yet. We're gonna add this, so 0.8435, 0.8435, that's gonna be 5 times 25, 3 times 5 is 15, this is gonna be 17, so 4 times 5 is 20, that's gonna be 21, and then 8 times 5 is 20, that's gonna be 40, that's gonna be 42, 3 times 5 is 15, that's gonna be 10, 4 times 3 is 10, that's gonna be 13, 8 times 2 is 24, that's going to be 25. 4 times 5 is 20, 12, 14, 16, 17. 8 times 4 is 32, that's going to be 33. What was that? 8 times 5 is 40. 8 times 4 is 24, that's going to be 80. 8 times 4 is 20. 8 times 4 is 32. Wait a minute. Wait a minute. 8 times 5 is 40. 3 times 8 times 3 is 24, that's going to be 28. 8 times 4 is 32, that's going to be 34. 8 times 8 is 36. 36. Let me 64. That's going to be 67. 0 point right there. 12. 2. We're not even halfway done yet. Okay. 2 times 3 is 4. 5 plus 4 is 9. 4 plus 5. Like maybe 9 plus 15. That's gonna be 24. 7, 9, 11, 71. That's gonna be 0.7114 plus that's gonna be 0.749. Let's just round it to 4 decimal places. 0.75, 0.8435. That's 5 is 25. 5 is 15. That's gonna be 17. 4 times 5 is 20. That's gonna be 21. 8 times 5 is 40. That's gonna be 42. A435. A435. And 35. And that's 7 times 3 is 21. That's gonna be 24. 3 times 4 is 28. That's gonna be 30. That's gonna be 8 times 7 is 40, 56. That's gonna be 59. 2, 5, 8, 10. Okay, that's gonna be 8, 10, 15, and then 12 plus 8, that's going to be 20, 21, 10, 60. So that's going to be... Wait a minute. This is not the actual answer because I need to divide it by 2 factorial, which is 2. Oh, sorry. I almost forgot. I thought I forgot. So 2 times 5 is 25. 35, that's going to be 70. 2 times 5, 10. 2 times 7 is 14. 5. This approximation should be 3, 5, 5, 8 plus 0.6, 0.6002 over 6. That's obviously going to be 0.1003. 0.1 plus wait a minute. 0. Oh, the next multiplication would, I think it will be easy, really easy one. Zero point 8435 plus times 0.6002. That's gonna be 870. That's 6. 1, 2, 3, 30. 6 times 3 is 18. Gonna be 21. 6 times 4 is 24. 7, 26. 7, gonna be 50. 87062. 5. That's gonna be 0.5062. going to be 0.5063. 4 factorial. That's going to be 24. 0.5063 over 24. 0.02. That's going to be 48. Okay. And then 2, 6, 2, 1, 2, 4, 2, 3, 1, 0.0211, and then we multiply it again. It's gonna be, wait, is that even correct? Let me check. 0.8435 squared over 2 factorial. Okay. 3 factorial. 4 factorial. So up to this is correct, but for the next one, I'll calculate it by hand. Otherwise, that will be cheating. 5063. That was 3 factorial, 4 factorial, 5 factorial. Let's should enter 5 factorial. Anyway, 0.8435. 15, 9, 10, this 12, that's going to be 13, maybe 34, that's going to be 25, if I is 30, 18, 20, 6 times 4 times 24, that's going to be 26, that's going to be 50 right there, going to be 25, 5 times 3 is 15, it's going to be 17, 5 times 4 is 20, that's going to be 21, 1 is 40, that's going to be 40, 2, 3, 0, 5, 11, 16, 10, 7, 4, 2, 7. So that's going to be 0.4271. We're going to divide by 5 factorial, which is 120. So we got, let me erase this, 0.4271 over 120, that's going to be 0.0003, that's going to be 360, 2712, that's going to be 240, 310, 0.0032, and if we continue, we get it's gonna be that's gonna be 0.4271. 8435. Maybe 12, 21, 22, 8, and 10. 8 times 7 is 56. That's going to be 57. 70, 8, 16, and this is going to be 20, 12, 12, 14, 16, 17, plus 32, that's going to be 33, 0.556, 5, 12, 19, 20, 13, 18, 20, 5, 6, so that's going to be 36. What are you doing? 0.3601. So if we divide it by 6 factorial, which is 720, which is 720, 0.000 5, that's going to be 36, That's gonna be 0.035. Let's just add that to it already. So that's gonna be 0.037. And I don't think that's gonna be the end. Okay, 7 factorial time. 0.3435. Let me check. By the way, let me check. 0.8435 to the 5 over 5 factorial. Oh, wait a minute. Where did I go? 5 factorial. I don't think that's correct. Huh? Why did I divide by 0? 4, 2, 6, 7. It's going to be 5 factorial. Okay, that's correct. So, what about 6? 0 point. Wait a minute. I don't think it's correct. Though. Let me check for a bit. 3601, okay. 6 factorial. 0.3601, that's a bit correct, but let me do the division again. That's gonna be 720.0005. Oh yeah. 5. So that's gonna be, of course that's gonna be 0.004. Okay, 7 factorial. That's gonna be 0.3601, 0.8435, 30, and then 6 times 3, that's gonna be 7 times 3 is 21, and then 6 times 4 is 24, that's gonna be 26, and it says 48, that's gonna be 50, and then 3 times 5 is 15, it's gonna be 10, and 4 is 12, that's gonna be 13, and 4 is 24, that's gonna be 25, 4, 35, 13, 14, 7, 3, 30, that's gonna be 0.30. And then we're gonna divide by 720 factorial. 7 factorial, which is 5040. It'll be 0.000056. That's gonna be 0.001. That's gonna be approximately 0.0001 factorial. That's gonna be 1 right there. So we're gonna add all these up. And then we're gonna raise it by 0.6699. So we have, let's all add all of them up. I think I need to do quickly because too much time has already passed, but we're only halfway done yet, so let's be quick as possible. 8, 10, 14, 15, 10, 12. Okay, 10, 13. Maybe 2.3245 times 10 to the 9, 6699. So that's gonna be approximately 2.3245 times 10 to the power of 6699. So, wait a minute. 26. Look. 26 minus 6699. I'm gonna raise it to the power of 10. So it's not really accurate, but it's just accurate to 2 decimal places. The actual value is 1.7845 times 10 to the 6699. But this doesn't. I use the value, okay? Huh? I think I'm gonna get my pillow. So 2026 to the power of 1 over 2026. Oh, that's gonna be a big challenge. So what I'm gonna calculate was 2.0261 over 2026 is e to the natural log of 2026 times 1 over 2026. And then we're gonna use something cool. And then natural log of, so that's just 7.6133. And then that's gonna be 2026 right there. 0.003 right there, that's gonna be 18. 76, 0, 13, 5, 3. That's gonna be 53. Wait, please wait for a second. Let me drink my water. Okay, I'm back. This is taking so long, but I'm just trying to do it anyway. 2 times 642, and then 2 times 114, that's gonna be 18. It's gonna be 14. 1, 2, 15, 7, 1, 4. Should we divide by 5? 3, 10, 13. So that will be our approximation is 0.0038. And then if we try to use the Taylor series, we get 1 plus 0.003a plus 0.003a square over 2 factorial plus and so on. That's gonna be 1.003a plus this term. Is it less than 0.0001? Let's check. 0.0038, 0.0038. That's gonna be 64. This is 24. That's gonna be 30. It is 24. 300 is 9. That's gonna be 11. 1444. 00000. That's just practically 0 if we round it to 4 decimal places. So this is our approximation, which is 1.0038. But what about e to the 2026? Oh well. What am I gonna do about it? E to the, let me erase this. E to the 2026. E to the 2026. I'm not gonna calculate that. It's gonna be a really large number, but not as large as 2026 to the power of 2026. But it'll still be really, really large. Let's just do it, okay? Let's just try to do it. Let's try to approximate the value. So that's gonna be 10 to the logarithm of e times 2026. The logarithm of e is approximately 0.434 times 2026. 2026 0.434. 24, 8, 10, 8, 18, 6, 7, and then it's gonna be 6 right there. Wait a minute. 8, 1, 0. 10 to the A7, 9.284. Then we use the same trick that I used earlier. So that's gonna be 0.284 times 10 to the power A79. Let me check that a little bit. So that's 6 times the logarithm will be, it's gonna be A79.284, blah blah blah. So I think that's gonna be our approximation. So that's gonna be e to the natural log of 0.284 times the natural log of 10. The natural log of 10 is approximately 2.3026 times 0.284. Like that 124, 8, 10, 12, 9, 8 times 6, that is going to be 48. 2 times 8 is 16, that's going to be 20. 3 times 8 is 24. 24, that's going to be 2 times 9 is 18. 72. No, I mean 52. Well, that's going to be 0. That's going to be 46. That's going to be 0.0 right there. 8, 4, 3, 9, 13, 8, 14, 15. 0. E to the 0.6539 times 10 to the power of 879. Okay. So that's gonna be, we're gonna use the Taylor series again. So it's gonna be a long video because we still have 4 more left. It's gonna be really long. So that's gonna be 0.6539, 0.6539. 9 times 9 is 81. 3 times 9 is 27. 27 plus 8, that's gonna be 35. 5 times 9 is 45. 48. And 6 times 9 is 54, that's gonna be 58. 3 times 9 is 27. 9, 11. 5 times 3 is 15, that's gonna be 16. 6 times 3 is 18, that's gonna be 19. There's 45. 5 times 3 is 15, that's gonna be 19. Minus 45. I mean, 25, that's gonna be 26. 6 times 5 is 30, that's gonna be 32. And then 6 times 9 is 54. I'm really tired now. That's gonna be 18, 19, 20, 23. 0.10, 15, and then we're gonna have 10, 20, 28, and then we're gonna have 18, 20, 25, and then 6, 7. 4, 2, and then we're gonna divide divide by 2. And then we're gonna divide by 2. We're gonna divide by 2. Which is 2 factorial is just 2, okay? So 0.214273 is 6. 15. 7 is 14. 9. So that's gonna be 0.2. Approximately 1.39 plus 0.2138 plus. Oh, I know how to calculate this term. We're gonna take this term, multiply it by 0.6539, and then we're gonna divide by 3. So 0.6539, 0.2138, and then we're gonna divide by 3. Okay, 9 times 8 is 72, and then 3 times 8 is 24. That's gonna be 31. 5 times 8 is 40. That's gonna be 43. Say 48, 52. It's gonna be 27, 9, 11. 103 is 15. It's gonna be 16. 600 is 18. It's gonna be 19. And then 6, 5, 3, 9, 18, 78, 10, 12, 13. So 0.013. Okay. 10, 20, 12, 21, 23, 23, 28, 9. So that's gonna be okay. So I'm gonna divide it by 3, and then we get 4 is 12, 3 is 9, 9 is 27. So this is an approximation for 3, 9. Two, 1, 3, 8. So I think we have point. Then we're gonna multiply it by. What's this? Apple? I don't think so. So that's gonna be 0.6539, 0.0439, 81, 27, 35, 45, 48, 6 times 54, that's gonna be 58, 3 times 27, and these 9, that's gonna be 11, and these 15, that's gonna be 16, 19, so that's gonna be 4 times 9 is 36, 4 times 3 is 12, it's gonna be 15, and if it was 20, that's gonna be 21. 6 times 4 is 24, that's gonna be 26. 2, 16, 11, 12, that's gonna be 20, 10, 17, 8, 2, gonna be 0 point. Wait a minute. That's just like 0.007 and 0.00428. So yeah. So are we done yet? No, I don't think so. And then we're gonna divide it by 4. I'm gonna divide it by 4. So that's gonna be 0.0 whatever. 07, that's gonna be 28. 7 minus 4, that's gonna be 30. That's gonna be 0.0072 plus and then 0.6539 over 0.0072. That's gonna be 72, 78, 13. So times 9 is 63, so 3 times 9 is 21, so it's gonna be 27. 5 times 7 is 35, that's gonna be 37. 6 times 7 is 42, that's gonna be 45. Zero point 0047, and then we're gonna divide it by 5. So that's gonna be 5 times 9 is 45. 5 times 4. That's gonna be 0.0009. That's gonna be 0.081. We're not done yet, okay? It's gonna be 0.0009, 0.69, 6539, 81. 3 times 7 is 27. 35. 27 plus 8, that's gonna be 35. 5 times 9 is 45. 48. It's gonna be 6 times 9 is 54. That's gonna be 58. This is, and then we're gonna divide by 7. No, I said we're gonna divide by 6. So it's gonna be 0.001. This is gonna just like that, and then we're almost done. So that's gonna be 0.2138, 0.0439, and 0.0082. So that's gonna be 10 plus 18 is 28. And then 3 times 3 is 9. 9 plus 8 is 17. That's gonna be 19. 10, 11, 8, 9. It's gonna be 1 point. So it's approximately 1.9198 times 10 to the power of 879. So that's gonna be approximately 1.9198 times 10 to the power of 879. So this is a good estimate. I'll use the right calculator to check. So e to the 2026. Oh, it gave me an error, but I can still check it. 2026 log. 2026 log e minus 879. So it's not really accurate. No. So it's not accurate to even one significant figure. The actual number is 7.7 6 times 10 to the power 879. So it's not accurate. So what about 2026 factorial? It's gonna use the Stirling approximation. So what I'm trying to say, e to the 2026. So that's gonna be 2026 factorial. It's approximately 2026 over e 2026 times square root of 2 times 526. That's gonna be 4052 pi. Okay. And then we're gonna have. So I'm gonna calculate this the easiest way possible. So for this square, not gonna use the Newton's method, but because it's still difficult to calculate, so I'm gonna use the long division method. Pi is approximately 3.14164052, and that's approximately 62832 38 27 15 24, and that's going to be 6. It's going to be 56. Going to be 12 and 32, 16, 6, 7, 13, 19, 12, 13, and then 7, 12, gonna be, and then, so I'm gonna take the square root of this thing. So the square root of 120,739 and 7652. So I'm gonna approximate this, and then we're done. So 1, that's gonna be 2739. I'm gonna use a quick way to measure that. And then 27. 2 times what? 2, 121, 69. 6, no, not 69, it's 639, 221, 22, and this is gonna be 6, 9. So no, it's gonna be 2. 2 times 2, that's gonna be 4, 4, 4. 1, 1, 2, that's gonna be 5. 9, 1. And that's gonna be 7, 6 right there. 2, 2, 4. 7, no 9. I think so. That's gonna be 9. 81. 4 times 9 is 36. That's gonna be 44. 2 times 9 is 18. That's gonna be 22. And I think that's gonna be 20. Oh no, we're not going for this. So we're going for 8. Wait a minute. Gonna be 8 right there. 8, 8 is 64. 4 times 8 is 32. That's gonna be 38. 8 times 2 is 16. That's gonna be 19. 8 times 2 is 16. That's gonna be 17. 2, 4, 17. 9, 0, 0. And that's gonna be 8, 14. That's gonna be 5. It's gonna be 6. That's gonna be 2. 8 minus 7. That's gonna be 1, 2, 2, 5, 6. Dot here. 2 2, 1, 1, 2, 8, and then 7. So 7 and 7 is 49. 7 and 7 is 42. That's going to be 46. 35, that's going to be 39. 7 is 14. That's going to be 7. 14, so that's going to be 17. 14, that's going to be 15. 3, 1, 8, 11, 2, 8, 0, 0, 2, 8, 7. Let's just take this as all approximation. This one is 1, 1, 1, 2, 1, 8, 7. So it's gonna be 20. That's just gonna be 10 to the power of 20, 26, and the logarithm, which is going to be split up using logarithm laws. This is let me check. So if log 2, 3, then this is gonna be log 2 minus log 3. So they're just true. So 2026, that's gonna be logarithm of 2 times 3.3064 times the logarithm is 0.4343. I said that was 4.34, but now I knew what it is. It's just 4343. 1, 2. Okay. I think I should do this. 1, 7, 2.8. 2.8721. And then that's going to be 2026, 6, 12, 7, 42, that's going to be 43. This is 48. It would be 2. And then 2 times 6 is 12. That's going to be 17, 42, 14. Is that 16? That's going to be 17. That's going to be 5. 5. That's going to be 4, 6, 7. And then 8, 18, 9, 10, 11. 8, that's going to be 5, 8. 1, 8. It's going to be 10 to the power 0.8746 times 10 to the 5, 8, 1, 9. Oh, another e to the x again. So that's gonna be that's gonna be 10 to the power, so e to the power. This times the height times 2.3026. 0.8746 to 34, 27, 2, 52, and then this is gonna be 12, 92, 14, 12, 16, that's gonna be 17, 18, 12, 13, 12, 21, 22, and it's 24. And then we'll make it wrong. That's just wrong. This is 18, 12, 13, 21, 22, 24, 26, 1, 7, 4, 9, 2, 9, 6, 11, 15, 5, 10, 18, 10, 13, 11, 20. So that is going to be equal to the 2.0139 times 10 to the 5819. And then, well, e to the 2 times e to the 0.0139 times 10 to the 5819. So that is going to be, well, 7.389. That's going to be our approximation. 389. That's going to be our approximation. That's going to be all my approximations of e squared. So that's going to be 0.389. So yeah, it's correct. Well, what about this? So that's going to be 1.014. One point zero one four. Let's check. Use that 0.0139. That's gonna be 1.014. So yeah, that's correct. So this is gonna be times 10 to the 5819. 7.389, 1.014, 36, 32, that's going to be 31, 12, 15, 29, 7.389, 7.389, 14, 13, 14, 18, 18, 22, 9, 11, 19, 7, 4. Put a decimal point right there. And then we're going to multiply it by. So this is. So 7.4924. That's the answer to this gigantic exponent right there. So that's gonna be, we're almost done. How many? I don't think so. 112.87. With 16, that's gonna be 17. 5, 2, 2. 9 times 7 is 63. 9 times 8 is 72. That's going to be 78. 2 times 9 is 18. 25. 11. 10. Okay. So 4 times 7 is 28. 4 times 8 is 32, that's going to be 34. That is 8 plus 3, that's going to be 11. 5, 4. So that's 7 is 49. 7 is 56. 60. 7 4 is 7 2 is 14, that's going to be 29 cents. So it's gonna be 10, 16, 21, 22, to 22, 6, 5, 84. So this is gonna be 8.4562 times 10 to the 5821. So that's gonna be our approximation. But what about sine of 2026? Well, if you want degrees or radians, I'm saying that it's not clear if you want radians or degrees, because comment down below about what value of sine of 2026 you want, radians or degrees, that you want me to calculate in the next video. So let's just skip that one, right? Skip this one. That's gonna be skip this one. Let's just skip. So I'm gonna skip this. Okay, what about the bring radical of 2026? So if, in case you don't know, if bring radical is that it's x and x to the fifth plus x plus z, and that's gonna be 0. It's like a solution to the quintic equations for polynomial equation of degree 5. That's gonna be a topic for another video. So we're gonna solve x to the fifth times 2026. That will be the value of the bring radical of 2026. So let's just take this our function. The derivative is going to be 5x to the 4 plus 1. So let's try 4. What could the x0 be? It should be 5 to the 5. That's gonna be 3125 times 25. 25 times 5. 3125. I don't think that will work. But how am I gonna calculate this? That's gonna be f of 1, that would be 20, 27. F of 0, that's 20, 25. F of negative 1 is gonna be 20, 23. Oh, what the heck? So f of negative 5, that should be negative 3125 plus 5 plus 20, 26. 625, 25. 5 to the 5th power, that's 3125, right? No. Yes. Oh, yes. 3120, 20, 26, 3120. 5 plus 20, 26. That's gonna be. Let's subtract. So that's gonna be negative 1, 0, 9, 4. F of negative 4. That's just going to be wiggle. This thing is just wiggling around. F of negative 4. Negative 4 to the 4. 4 times 4 times 4 times 4 times 4. 16, 2, 5, 6 times 4. 0 to 4. plus 1020 2026. It's gonna be 20 1024 plus 4 plus 20 26, and that's gonna be negative 1 0 1 6. Gonna be positive 1 0 1 0. I think that's gonna be halfway between them, so let's just use 4.5 as our first guess. And because I'm already tired, so I'm gonna only use one iteration to get a fairly accurate result. So that's gonna be 4.5 minus 4.5. Negative 4.5, of course, that's gonna be negative 4.5. And then also that's gonna be 5. I'm really tired now. Negative 4.5. Negative x to the fifth can be also written in negative x to the fifth, so let's just compute x to the fifth first. So we're gonna compute 4.5 and then we're gonna negate it. 4.5, 4.5, 20.25, 20.25. Okay. 1, 2, 5, 10, 50, 0, 4. 4, 0, 5, 0. Okay. $400, and then we're gonna multiply by 4.5. 4.5. That's gonna be 3, 1, 2, 5, 0, 5, 20, 100, 2, 5, 0, 4, 16, 1, 2, 5, 8, 2, 5, 4, 8. So let me check with my calculator. 4.5 to the fifth. 5, 4, 5, 1, 2, 8, 1, 2, 5. So that's correct. And then it's already negative, but if we subtract 4.5, that's gonna be negative. Let me erase this first. Subtract negative 4.5. That's gonna be adding. Like this, that will be like adding. And that's gonna be 9. And then we're gonna subtract 2026. Subtract these numbers right here. So 5, 9, 9, 9, 9, 10, 5, 7, 8, 1, 2, 0.1, 15, 6, and then 1, 9, 11, that's gonna be 7, 1. So it's gonna be 176.2188. 21875, by the way. And if we divide 1849.78125, if we divide, we get 4.5 to the power 4, but negative x to the 4 is just x to the 4. Okay? I'm already too tired to explain why. So that's gonna be 2, 2. Wait a minute. I mean 4, 20. 4 times 4 is 16. That's going to be 180. 4 times 5. 25. 225. Let's just say, wait a minute, that won't do anything, so let's just prox 2025. 2025. It's gonna be 4100.625. Let me check. So that's gonna be 4100.625. Let me check first. Fit. So if we try to divide, we're gonna see that 7, 6, 2, 1, 8. 4100.62. 0.0. That's gonna be 16. Minus 20. 11. 24. That's gonna be 25. 0. 4, 6. T. 19. 2. 1. It's gonna be 43. I'm gonna be 75. 18. 0. 12. I don't think so. Maybe 42. But 2. 82. It's gonna be 592. And 9.94. I think 0.045 will be approximation. That's gonna be approximately equal to minus 4.5425. So the ring radical of 2026 is approximately negative 4.5425. I think that's the best I can do because I'm really tired right now. I'm sorry. Okay, I think so this will be the end of our video. So what I did was I did all of these calculations. That was not accurate. That's a really terrible approximation. That was really sad. So my challenge for you is to compute this. Approximate this without a calculator, and comment down below about whether you want me to calculate the sine of 2026 in radians or in degrees. So this is the end of our video. Goodbye.